Good morning. Welcome to today's webinar. We're going to talk about landscape, LOD, and VDC design to build. We have the presence of Lauren Smith and Rado Dicker. Lauren is a licensed landscape architect and design technology specialist at Parallax team. With 10 years of experience using Revit specifically for landscape design, she leads the landscape effort of Parallax. Rado Dicker, he embarked on his career in the AEC industry over 20 years ago as a field engineer for an architectural office in Chicago. In 2020, Rado joined SWA Group, the largest landscape architecture, urbanism, and planning office in the US. And Dr. Will Iker, PE, PhD, is Director of Research and Education at Beamform Global. Dr. Iker will be moderating today. Welcome.
Thank you, Luisa, and thank you, Radu and Lauren, for your time today. One of the things I was looking at as we were preparing for this, Radu, I also wanted you to share just some of your background over that 20 years. You've got a very eclectic compilation of skill sets, and I think one of the things we're going to talk about today that you highlighted on is just the role of integration when it comes to landscape. And after that, Lauren, I also want you to share some of how you're really creating synergies between technology and landscape architecture as well. But Radu, how did you really get introduced into the AEC industry?
It was a matter of chance. I was actually a physicist with a couple of masters in history that was given an uncanny opportunity to try architecture in Chicago, and I could not say no. I think one of the things that physics teaches, graduates is to do most other things that are possible to be done. So that also helped me then do MEP, and essentially, I think one of the things that BIM professionals need to do very well is talk to all trades. And as I mentioned to you, I think the role we play in projects is to be integrators, to speak all languages and make sure that the project as a deliverable is essentially integrated and cohesive.
Definitely. And Lauren, tell us a little bit more about your background. You are a licensed landscape architect, but then also you are an author, you writer, you have your own blog. And so if you could just expand more on that background and how you got here to what you're doing.
Sure. Yeah. So my background is more traditionally a landscape architect. Yeah, I got my undergrad in landscape architecture. And I sort of ended up shortly after undergrad, I ended up at a firm, an AE firm, that had been doing BIM for a little while, and they had a small landscape site group, and they were sort of interested in pulling us as sort of like the last standouts along. And so I was able to sort of help lead that effort. And through trying to learn it, I discovered there was just a big gap of big knowledge gap out there. So I kind of started my blog, Land Arc BIM, as a way to just kind of share so that not everyone else has to reinvent the wheel every time. So that's sort of was the start of my BIM journey, and it continued from there.
And from your perspective, you had brought out that you're going through a more traditional way, and we're going to dive into some really amazing projects both of y'all are working on today. But what would you share with a student today that's studying landscape architecture? I'm assuming you may have had just traditional 2D CAD, or what was what did you see as you went through to become a landscape architect, and what would you recommend for others today?
Yeah, I think that is a challenging aspect because I think the educational realm can sometimes lag a little behind, but also they have so much to cover in such a short span that sometimes it falls on practice to learn even just AutoCAD. We learned very basic AutoCAD in undergrad. And I would say I actually came in with a bigger foundation. I was lucky, and I was exposed pretty broadly to 3D modeling and AutoCAD actually in high school. So I came with that background already. So it probably gave me a slight leg up than the average landscape architect. But I would say, yeah, if you have the opportunity to kind of learn it or go for it, to just do it, because you can't necessarily, yeah, you can't necessarily rely on like broader institutions to be up to speed on like the cutting bleeding edge of things.
No, that's a good point. Yeah, and that's something we've seen in a number of professions. A lot of feedback I've gotten from professionals that have really done great work in the VDC realm is that they started with 3D modeling in high school, and then it was just an enabler and enhancer to whatever career learning path they took. They just brought VDC into it as they went. In this order, we're going to do this as a dialogue, and I really want y'all to start leading. We'll go in these, but if we need to go back to a different topic and dive into it more, but with this, I'll turn it over to y'all.
And before we do that, we just want to say I've seen this happen in industry in different stages. I mean, CAD with architecture. I was involved in implementation in the early 2000s. MEP in mid 2016. Is when I started seeing graduates not knowing CAD anymore. Right. So there's like sort of paradigmatic shifts that happen, and there's excitement when these graduates come into the trade. And they start doing that, doing the work.
Definitely. I see it happen a lot in companies that I've interviewed that have high school interns learning laser scanning and 3D modeling. And really, if they know algebra and geometry, there's nothing holding them back from really excelling with some of this if they're just interested. So it's an interesting trend. I hope to see grow for all our sakes. The AEC industry needs a lot of talent, and so this is good stuff. What are we looking at here?
I don't think we're sharing the screen yet.
We're not looking at anything yet.
Am I missing something?
Now we're going to see something.
Yes, I think so. We're gonna essentially talk about at the beginning, at least, and we're hoping to transform this into a dialogue. I mean, about the beginning of the implementation of BIM to the landscape architecture discipline, which may seem to mirror the cryptic perception of hieroglyphs, because as much as they've been legible for a certain amount of time, they still inspire a sense of mystery and a certain otherworldliness. Right, and I think what we're proposing is that not the case. That there's a practice of doing BIM for architecture that's happening today. In that said, AECO has been dominated by BIM for a good couple of decades, and in the practice of most trades, BIM is pretty long past maturity, and steadfastly transnational norms and standards such as ISO 9650, COBE, IFC are essentially streamlining projects around the world, which are executed by global teams. The two trades we'll be focusing on that may still be a bit shy of fully taking the plunge, and I'm more looking forward to, pose this challenge to Wills for his thoughts: landscape architecture and civil engineering. One of our explorations today is why and how can we together fully step into the BIM world and beyond. As much as I will be presenting challenges, I want also to state that we are currently navigating these challenges, and there's an increasing number of solutions, which we'll also look at. As a major part of the path forward, though, is improvements of the main industry tools by their makers. Another point I want us to make. Keen attention and focus on our scope and greater catering to it is a critical part of adoption in the industry. Next slide, Will, please. So to that end, the coordination between landscape and civil, I think, is a hot topic. And I want us to look at why shy, why maybe still landscape and civil are a little shy of adoption. And in my practice, as well as Lauren's, the practice will reflect mostly use of Revit as a BIM tool. So I'll be probably mostly Revit-centric in my points, which is, in my experience, by far dominating the domestic international scene. But other platforms live in similarly heterogeneous ecosystems. As civil engineers tend to use Civil 3D, an accepted BIM program, and landscape architects tend to use Revit, internal dissimilarities of core engines between Civil 3D and Revit make full integration challenging. And this integration needs to account for seamless and streamlined sharing of project coordinates, for instance, for one item, typically owned by Civil, which then need to support full live linking of all elements in their respective scope of both trades, and therefore enable delivery of essential and expected products, such as 3D coordination, visualization, quantity takeoffs, cost estimating, etc. Right? In terms of BIM users, and we'll look at BIM users later a little closer. From our vantage point as landscape architects, depending on the civil scope items such as roads, parking, site utilities, piping networks, grading surfaces, tunnels, and so on, a very eclectic set of tools, none functioning ideally needs to be employed. Next slide, Will, please. And there's a range of tools again. Each one of them catering and providing certain segments of scope from civil into the landscape and architecture and other trades realm. Some of those are live linked topography, which is a major step forward a few years back. 3D CAD, IFC, and I'm mentioning different file formats which all have to be integrated slightly differently. Navisworks files through coordination model linking, point clouds, land XML. And overall, Autodesk has been offering some tools that have not necessarily been maintained very well or allowed to reach a satisfactory level of maturity due to iterative improvements, which is why, and next slide, Will, please. There's a wide range of other tools coming from the field, catering to basically horizontally, if you want, from landscape specific Revit add-ins such as Lauren's foreground, and she's probably going to talk more about that, or environment, another similar tool, to wide-ranging impact tools such as Rhino Inside, which when used appropriately are particularly able to cater to such a free-form, organic, natural systems-driven design as landscape architecture presents. The complexity of adopting these solutions is in fact inspiring, I think. It's also cutting edge and finding a conducive home in applications such as digital twin, machine learning, and AI. The keen interest in sustainability and environmentally responsible design also opens an exciting wide range of possibilities due to specifics of landscape architecture scope. I think BIMUSE B11 by Penn State version 3, which pertains to analyzing sustainability performance, is a particularly an exciting deliverable for landscape architecture scope, and coordinating with civil particularly offers some unique opportunities in delivering B11 in areas such as water management, heat island effect, shading, and other such applications. Next slide, Will, please. Expanding to project-wide coordination. Another point of difficulty has been in our experience as landscape architects, a certain reluctance by our civil engineering project teams to embrace solutions such as BIM 360 or Autodesk Construction Cloud as common data environment implementation. And I'm also looking forward to Will's thoughts on this. For instance, the most optimal coordination point that is currently offered, live linking topography, is rather seldom being used, as it requires adoption of the CD by the civil engineering team. In order for the overall project deliverables, many times to offer BIM USB B13, which is 3D coordination, landscape architecture oftentimes occupies a critical role of coordinating between civil and architecture and the rest of the trades, because of our sort of connecting tissue nature of the way we come into the project.
Yeah, and I think you've alluded to the coordinates earlier, and probably the most collaborative work I've seen is really when the design's flowing down into the construction side. And what has really made things work the best, it's really just sociology, getting the right people together. There are different pathways to achieve this with the technology. And what I normally see holding it back is that we're not getting the communication we need from utility contractor, general contractor, site grading, irrigation installation. And some of them, it's just finding a way to make small adjustments in their businesses so that they're willing to share the information in a timely way. So ironically, here we are, a decade into doing landscape architecture projects in BIM. And I think the software has come a long way. We're still getting challenges with some owners having US survey for their survey control dimensions, and all their Revit models are in US international feet, and their origins are 7,000 to 7 million feet away. And so once you start doing just little, like a unit change, international feet to US survey, you can create large discrepancies. And it's not the software's problem. This stuff's known by some, and it's going to be communication, I think. And that's part of what this webinar is about. How we, bring technologists, civil engineers, landscape architects together and start looking at how we come together.
I sometimes feel there's almost blind spots that are esoterical in a way. And I think for a long time, a communicator was missing from the projects a lot of times, which is, I think, us, landscape architects and civil engineers. But landscape architects, I think, and I think this is where my MEP and architecture project management background come into play, the breadth of and the width, if you want, of experience is critical, because we're going back to that language interpretation and sort of communicator and integrator role. There are sort of certain specific aspects which are like the one you mentioned, Will, and sort of utilization of internal origin and project-based point and survey point and other things like that, with their implications, which are the blind spots. Sometimes there isn't a knowledge of very sort of slicey, if you want, aspects that are important to project-wide coordination.
All good points.
And let's see. So talking about project-wide coordination, I think I'm going to go to the next slide. Which makes another point where I think landscape architecture comes in very importantly. And I haven't necessarily pointed to imagery on the slides, but I want to just like look at this slide and be inspired, if you want, and let it sort of talk to us about its free form and wild design. And we do this all the time. This is basically our scope. Now, another major expected deliverable is B12, design review, and I'm thinking specifically of visualization, and it's critical for the legibility of a project through its life cycle, right? The capacity to assess and understand design, make inspired decisions timely and appropriately at all project stages, and all that relies in visualization. And integrating Civil 3D and Revit from this perspective is also a point of that can take improvement. Sometimes landscape architecture has had to provide visualization product for other scope, including civil, to provide context for our visualization, which is such a critical part of our deliverables, which breaches into one of the tenets of the common data environment, the single source of truth principle, and necessitates careful management of cost and of the ownership of elements, right, which pertains to the single source of truth principle through the project life cycle.
So one thing about this, Radu, I want to think about, and Lauren, you as well. In my own profession, we've been working, in civil and structural engineering and enclosure design. We've been working towards the model is deliverable, and due to permitting and other reasons and owners and preferences and historic precedents, we still have a lot of 2D documentation that must be done. We're sealing those drawings. We get our building permit. In the landscape side, well, first off, so one of the things we've seen in other areas of design profession is starting to use the models more with owners in making decision-making processes, instead of spending all the time to do a lot of 2D documentation for a design development package, and then a 50% CD, 75% CD, 90% CD. Literally, I'm going back a ways. We would spend thousands of dollars printing 2D paper for some owners, and now we're doing a lot of PDFs. But what we've been working on is using the model more to help owners make decisions and not spend as much of our time and fee design side making a lot of 2D documentation until we get a little closer to what we think the final solution will be. How have y'all seen that evolve over the last 10 years? Because previously a lot of 3D modeling on architecture side was used for very intricate renderings that were used by marketing and, say, development if you're selling a condo. But then the final building didn't always exactly look like those renderings that were done a year and a half ago. But are you starting to see visualization used with owners week by week in making decisions instead of having to make so many 2D annotation hours?
I think what I'm seeing will more of is is ownership participating visualization, but it's also contractors coming early into projects, right? Which also bring a very useful participation. And I think the distinction between the design model and the construction model is critical. There's different handling internationally versus domestically on that I'm seeing. But careful throttling of design effort is always an issue, right? I mean, how much, and it basically absolutely is a perfect segue into LOD conversations, I think. But yes, there's a lot of things going on technologically on visualization and VR, AR, and all these sort of virtual environments that I think can come in very usefully.
Yeah, I would chime in there that I think we are seeing a lot more like raw model usage on the client side, also on the design side. Like it's becoming a tool that I think leadership and like designers at firms are starting to rely on, like the ability to walk around a model digitally with a VR headset, and even using that in client presentations as well. Or with owners, depending on who exactly the client is. With landscapes, sometimes the client isn't the owner necessarily. It can become complicated. But yes, I would say that's a good segue into my first slide, where the next slide is, it is essential. I have a couple images of a model. This was actually a model that was built for an owner specifically to do a VR walkthrough of the landscape and the building together to fully kind of, I think, sort of like final approval I think towards the end of DD. But I think design might have changed some since then, but it was essentially an owner requested model for design purposes. Yeah,
Well,
and we're seeing that more, I think, early on. And I think that's one of the drivers to get landscape into BIM is that a lot of traditionally landscape models have been in programs like Rhino, they've been in programs like SketchUp, where like we can see the design, but it's not necessarily being collaboratively shared with the architect, with the owner, with the client. And so I think that's one of the pulls that's getting us like we're all at the same table, and so everyone can start to
yeah.
see the design more equally.
We've seen in areas using federation software that's used to bring together a lot of different models so you can navigate through it and walk through it. Are you seeing what might traditionally be clash detection software for model federation? Is landscape starting to use that more, bringing together Civil and SketchUp and Rhino and other platforms like Revit?
That's I mean, if I can speak of that, it's a high sort of request, right? I mean, 3D coordination is probably, historically speaking, the most high return or most sought deliverable.
Yeah.
But it is absolutely a need in our projects. A hot coordination item, civil versus landscape, is root balls versus site utilities. That's something that we're seeing all the time. And it even, what I'm seeing in my practice, it even traditional CAD deliverables projects we have, I'm seeing, because the skill is there, I'm seeing designers, I'm seeing project managers, and I'm seeing the team essentially using BIM for coordination, even if it's not a project requirement, just because of knowledge they have, because of the return they see, the advantage they see. So that's actually, it's almost, there's a ripple effect and a sort of capillarity, if you want, effect to this knowledge in utilization in projects. So even when that's not a requirement, having seen the return, the teams use BIM if available, even if it's not a committed product.
Lauren, are you seeing what might be typically, federation clash detection software used in landscape architecture, or how are you typically doing these walkthroughs with clients? Are they interactive, or are they a recorded fly through?
I think they're much more interactive than they used to be. A lot of software enables it to be either live in the modeling program and sort of clicking around, some VR. I think it varies depending on the software, depending on like what you're adding on to the software. I think the standard that you see a lot on the architecture side, and so landscape sort of gets pulled into that, is Inkscape. Because it's pretty easy. I think architecturally it produces pretty good results. On the landscape, there's always the challenge of plant material and like how is that being shown. And I think the preference for landscape architects is to get Lumion because of it has the widest depth of plants and like the plant variation, and you can match up like what your actual species are. But I think there is sometimes I think you can struggle to get that integrated with the architectural workflows because that's not what the architect is using most of the time. But it always varies depending on the project. Like for this VR walkthrough was actually done with Iris VR, I believe, and so we weren't. So we showed the plants like this, and they're these more like planar representation, but we were able to sort of make custom ones that essentially showed in a sort of low resolution way what the plants look like. So
That's another point I was going to ask you about, Lauren. Some architects we've interviewed have said early on they actually like a lot of their deliverables to look hand sketched, because it's early on in concept, and there's this dance, as they described it, with the owner in finding out what it needs to be, and they don't want to force too much photorealism even in renderings. Do you find some of that same interplay with landscape architecture, in that early on it's helpful for it to be more conceptual looking as you're doing a VR walkthrough?
Yeah, I think sometimes it's knowing your owner or client group. I think some clients like need the photorealism, and some, yeah, it can be a hindrance. So I think you
Got it.
can get it both ways. And so, and sometimes for plants, it can be very hard to sort of visualize without having the photorealistic aspect to it.
Good point.
So yeah, it is tricky, and I think it can vary depending on the project and depending on the client. Like there's no sort of one size fits all. That's how landscape architecture is. Everything, it's always different depending on the project.
Oh, good points.
And I guess the other point I was trying to make on this slide was just that the modeling is something that continues to be a challenge and has been challenging, but it is much easier. Like when I started 10 years ago modeling, it's just, I was doing everything out of the box. There was no automations involved. And eventually started using visual scripting and starting to figure that out. That was sort of my first foray into automation. And then I now, yeah, we create our own app, Foreground, which we use internally, and our clients use it as well. So it's a sort of constant feedback loop of, I'm in Visual Studio, writing in C#, thinking about like how can these tools. I'm modeling as well, so I get feedback from myself, but I also get feedback from our own clients about how we can incrementally improve these tools, like in the day-to-day for ourselves.
Excellent.
All right, so yeah, we can keep going.
Okay.
So these next few slides are a bit of a series, but we'll talk about this one. So I think the big impetus often for landscape to be unified in the BIM environment is often landscape on structure. It's not always landscape on structure, but I think that's sort of the low-hanging fruit that you see for landscapes. So this is a roof terrace. This is actually the I'm locally in Seattle, and so this is the new convention center that is actually currently built. But this was the big roof terrace. So it's a pretty big roof terrace. I don't remember the square footage exactly, but you can get a small sense of it here. And that, again, the 3D model was a very useful design tool for like us internally. This was when I was still at GGN. This was a project from past life, but I think it's a very good example of where you can start to reap the most benefit from having a landscape fully coordinated. So if you go to the next slide, we'll start to see another, the big benefit is, and we do implementation for what we call implementation at Parallax for clients who are wanting to transition from AutoCAD into Revit. And this is the other kind of big thing that they're interested in seeing and understanding, is that your documentation is all pulled directly from the model. You're not managing the SketchUp model and then AutoCAD documents, and then there might be Rhino as well. And so this is that same roof terrace, which we have all these little walls, and this is just one sheet here, and I blew up one of the walls on the sheet so you can start to see the level of complexity that we had to do. And so it was very useful from a design perspective. I remember during the design process, we printed out some of these walls, like we had them roughed in, and then we printed them out on these really long sheets, and we like pinned them up in the studio so that we could like mark up the form, and then eventually it gets pulled into the model, and then the model is being documented like this, where we're pulling the live spot elevations, we're pulling the live like dimensions from directly from the model itself.
And was this project, this was all over existing structure?
This is all over new structure, but
New
it is
structure.
all over structure.
Okay.
So there are all sorts of seismic considerations, and these are just poured in place concrete walls. They have some texture to them, so we'll see that in some of these next slides here. So I think the next slide you can start to see. I actually
Wow.
just went and Google went and Google and was looking through, but this is like a photosphere that was done on the roof terrace. So you can start to see, this is from the same spot looking. So the bigger image is looking in it's the same vantage point that we had in the model. And you can see it's downtown Seattle, so you can see the surrounding buildings. So you're up pretty high, even though it doesn't necessarily feel like that. But yeah, you can start to see these very complex walls, and we also had these other hardscape elements. So the roof was a very interesting combination of these very sort of complex hardscape elements with a lot of native planting as well. So we were kind of working both angles, and we also had this very sculptural form with the softscape with the soil. So we did end up using, this is before foreground was built. We relied on some dynamo graphs to help automate some of this stuff, so that we could model it with actual, because it's all on roof deck, we had to model it with actual solid geometry, which presented some logistical challenges. But yeah, you can see it is now built and people are going there.
Well, yeah, like on average, what kind of soil thicknesses did you have over the roof?
So I think a lot of this is that you're seeing, like the big expanses are like 18 to 24 inch typical
Okay.
sort of shrub depth. And then there were pockets where you can't really see, but in this main vantage point, there are some tree pits that we were able to sort of carve out. The trees aren't very big yet. So
Yeah.
there are like smaller understory trees planted in the larger landscape. And then there are some big trees that will grow up sort of where that big Amazon building is. And that we were able to carve out more of like the typical 3 to 4 foot depth for those tree pits.
I see.
And basically, yeah, that was a big structural coordination point, was we had to carve these out underneath.
Yes. And a lot of mass put it right at the top of a building in a seismic area. So
Yes.
a lot of interaction at play. Beautiful project.
Yes, it was a big project, but it was fun to work on.
Okay.
And then if you go, I think one more slide kind of shows a couple of these things side by side again. So yeah, you can see the initial 3D model. So we did rely on a lot of VR to try to really understand the space because it's a big roof terrace, but we also wanted to create these like intimate spaces from a design perspective up here. And so again, you see some of the challenge of like planting material. Like we didn't fully model each individual plant just because it's a big area. But so a lot of that is can get the feel for it just from the landform that was modeled. And then again, you can start to see the walls. So these orange arrows here, you can see that's that same wall that we're seeing here. That wall there, yeah. And you can see it has the same form. And it has like, you can start to kind of, I think you can kind of see it in the photo, but it basically has this vertical board form. So it sort of like feels like a stone, even though it was a cast in place concrete wall.
So one of the things I'm seeing in this, and in the future, I guess the tree growth will go here, where I guess we're saying this was a large Amazon building going in. So I think that's also helpful for owners making decisions on where, why do we need to invest so much in structure to achieve these kind of deeper planting beds? And there's a value in it. That they can see beyond just some 2D stack of drawings.
Yeah, and that's a pretty good segue into the whole LOD conversation as well, because as we've discussed these past few weeks, plant material is notoriously difficult to model for a number of reasons. One, it's this organic thing that doesn't naturally, it's not created from just like base rectangles or circles. But then it also, yeah, it has this growth factor. So it gets installed at a size that you see in the picture, but then when you're thinking about the design, we often show it at 75 to 100% maturity because you want to understand eventually what that space is going to feel like when those plants are larger. But yeah, there's this a little bit of tension between understanding. You want the owner to understand what it's going to look like on install on day one, so they don't show up and be like, "Where are my trees?" So you have to sort of walk that line between understanding both at the same time.
So this is a good segue. I'm going to talk a little bit about the LOD spec. For those that don't know, BIMform Global has published the LOD 2022 version, and it's the first to include landscape in it, and a lot of the work really put forward by members of the American Society of Landscape Architects. First and foremost would be Lauren and Radu here. And what I'd like to do, Lauren and Radu, is flip through a few of the pages and just talk about the topics that are in there and then continue this discussion. So we might talk a little more about visualization. We might talk definitely about coordination as another big one. I'd like to also be thinking about talking about the part between design and hand over the project to the owner where construction is going on. Because we've had projects we've seen from teams we've interviewed where maintaining existing trees, protecting them. One city was doing an expansion to their arboretum, and the city had $10,000 to $15,000 penalty for every large tree of a certain size that that didn't make it through the construction process. So the general contractor in that case invested a lot of resources in modeling trees, tree root systems, and they felt like avoiding city penalties on existing trees more than paid for the whole BIM process. They got a lot of other benefits, but just protecting existing trees was their business reason. So as we look at the LOD spec, it's a new format in the BIMform Global 22 version. The element contents are on ledger size sheets. So they're 11 by 17 size sheets. And the goal of this was feedback from those we interviewed in getting the content into one sheet. And also it's broken in sections. So if you're dealing with landscape, there is a chapter, a section chapter that will really dive in to it. Radu mentioned interplay with civil and landscape. So we're going to talk some about paving. There is a section on paving, and we're currently working on the 23 version right now. Public draft will be out towards the end of October. And these are areas where I think you'll see more cross-referencing between the civil engineering section contents and those focused on landscape. We're going to talk about curbs, walls. Walls are another area that are going to cross-reference with retaining wall in the structural concrete section. Stairs and steps. Again, these will cross-reference in the concrete section. And something new to LOD specifications in general, and the BIMform Global LOD specification in particular, is that this specification is addressing tolerances. And next week's webinar is going to be dealing with, we're going to be interviewing Matthew Bird with Reality Capture Network. We're going to talk a lot about reality capture. But when we get into the discussion today, Lauren and Radu, I want to also be thinking about where you see the future. You know, owners using drones to do digital twin monitoring of the health of their landscape and how that relates to the fertilizer and irrigation that they're putting into it, where these models become a lot more than just a 2D documentation tool. But what you'll see in here is a section that I foresee will expand a lot in the next edition, but dealing with at an LOD 200 approximate or a 300 specific, there is the information used that might create 2D documentation, but what parameters are needed for visualization? And then Lauren touched on this earlier, that we're dealing with living content, and what does that look like in the size, and how does it affect coordination of its initial installed size, box size versus its mature size. So I want you all to hit on that some. Smaller plants and shrubs, soil planting, irrigation systems, and then the tree protection, which I talked a little bit about before that. But with those, just setting those topics as a table, y'all both were instrumental in really coming up with these topics. Lauren, I'll let you start there, and really just let this be a dialogue in the time we have left to kind of just, first question is, how did y'all come up with these to start with? Because you've also mentioned you're looking at these expanding a lot.
Yeah. So yeah, I think this is a funny story a little bit, but yeah, we have the BIM working group, which is a part of sort of umbrellaed under the digital technology PPN within ASLA. So we formed this maybe 3 years ago now. It's been a while. And so our initial sort of goal was to take a look at LOD specs and at how do they pertain to landscape architecture, because yeah, the LODs, like the BIM form LOD spec is so widely used. But we did see like there's some gaps within landscape scope, and how can we better apply these so that when a landscape architect is looking at this, they can clearly see without having to like really sit there. I mean, a lot of it is already in the LOD spec. If you take the time and really sift through, you can essentially come to these conclusions. But how can we assist landscape architects and sort to spell this out more quickly and more easily so that it's just more accessible to more people? And so that was kind of the initial goal. And then we started sort of like splitting out the elements. And we set a goal for ourselves last year before ASLA. In San Francisco to basically come up with these base ones that we could present and have ready to sort of roll in. And then this year presented itself, and so we kind of had them ready to go. But yeah, I think that the ultimate goal is that we'll have more, we'll get into more nuance and more specifics with other element types as well. But that's.
And I think because if I can kind of piggyback on your points, Lauren, I think because of our scope and the types of elements we work with, and this is a little similar with civil, I think, scope. There are particular aspects that do not exist, I think, to the same extent at least, for other disciplines. There are, and they expand into multiple BIM users. I think that's something we should be contemplating to include in the LOD spec potentially a little more. By that I mean certain deliverables. I'll give an example. I mentioned the root ball aspect of coordination, immediate on site. I mean, that's something that needs to be done early, and it's a high return item. At the same time, there's, on the other hand, if you want, there's growth, which basically goes into shading aspects and encroaching into building just visual reach from the building, if you want, and life cycle aspects, which are also distinct from other disciplines. Because, and I'll make a point here about the digital twin in a second, because I think it relates it connects very well. There are aspects to the trade that have to do with growth, entropy, erosion. There's a lot of sort of phenomena, natural systems acting on our scope, if you want, or that are our scope, that make them harder to predict and to anticipate behaviors of. I'll give you some examples. I mean, I think, and I'm involved in digital twin work with National Institute of Building Sciences, but I think it's been, as I've been working on this project on basically defining the relationship between BIM and the digital twin, I've been surprised to discover a lot of potential, I think, for the digital twin. Some examples I have, right, are because let's first define it, right? So the Digital Twin Consortium defines the digital twin as a virtual representation of a real-world entity and process synchronized at a specific frequency and fidelity. So that basically offers the feedback loop, which I think is what's important for us. And I'll give examples to flesh that out, to explain why I think it's so important. An example I can think of is the presence of invasives and then encroaching into the native plantings on a site, and the monitoring thereof, or canopy and other planting growth expansion data for shading, visibility, building maintenance, site maintenance, and other types of monitoring. Something that's done today to some extent is irrigation systems that are actuated by moisture monitoring sensors on site, weather data, and the weather data offers a two-way sort of feedback loop, right, from other types of data streaming other than sensors on site, right, because there's weather information that's available, or just visual monitoring systems like drones, as you mentioned, Will. Or shoreline erosion and sea level rise monitoring systems, and potentially outputting data into mapping and GIS systems, right? So on a different type, again, on different type of deliverable, if you want, or stormwater harvesting, collection, and management of fire conditions or fire events, including predictive. And this is, we're going into AI and sort of machine learning and things like that. Predictive based upon reported site conditions into models, into predictive models, right? And just the emergency events. It's something that I think it's a high type of scope for digital twin.
You know what, Lauren, want to get your feedback on that too. While y'all are thinking about that, one question that just came in is, looking at interoperability issues, are you encountering as you coordinate with other disciplines? What are you finding, and what are ways you're looking at overcoming the challenges when we look at interoperability and coordination? And some I can think of initially would be if y'all could speak to plumbing, maybe coming out of the building in, example of design authoring model like Revit, subgrade civil utilities and civil 3D, all the other myriad of applications y'all are using for visualization. When we're looking at interoperability with coordination, what are y'all seeing?
Yeah, I mean, I think what Radu said previously, civil is the big elephant in the room, but no one seems to quite have a great solution for. In regards to the other trades, like when you're in the Revit environment, generally everyone's there, and so it makes it's much easier starting point. Yeah, like the convention center project is a good example where we had a bunch. It was so much on structure. Even so much of the streetscape was also on structure, because it had huge, extensive basements. The plumbing, there was so much plumbing to be coordinated. Like even typical things at grade that you wouldn't think would have to be tied into the building had to be tied into the building. So I think that is it's sometimes still challenging, but it's still relatively straightforward because if you're both in the same program, then coordination as a baseline is much easier. I would say with civil, yeah, what Radu said was sort of the easiest thing to do now, and sort of the baseline is having linked topography come from your civil engineer, and that is something, but it's still not very much. It's still only like surfaces, and doesn't necessarily bring in utilities and all the other aspects of that is within civil scope. So that's a constant, and the scope overlaps between civil and landscape present additional challenges. So even if, in theory, even if like civil 3D and landscape were both unified in Revit, there would still be additional challenges that you wouldn't get between other disciplines. Like on this project, again, there was a lot of civil scope overlap with landscape, where landscape was owning all the pavement finishes for all concrete, like even in the right of way, even technically what would be civil. And so the civil would basically pick up grading at the right of way line, and we would do all the interior grading within the site. But even sometimes I've worked on a number of projects where civil actually owns all the grading, but landscape owns all the pavement finishes. And so it becomes this like, we need to model it because we want to see it in the model, but it's like as we start to show grading, that's not our scope, but we want to show it because otherwise it becomes a coordination headache. So yeah, so I would say there's no perfect solution for some of that stuff, and some of it is just trying to make it sure it's kind of clearly outlined in your BIM execution plan. Like this is where scopes are split. We might be modeling some of this stuff for coordination or for visualization or even just for convenience for ourselves. And I also, like on the programming side, we're looking to try to automate so that we can start modeling utilities in some way, but it's still sort of like early days with some of that stuff. But there are other interop tools like Speckle that I've looked into that in theory allow you to bring utilities between Civil 3D and Revit or other programs. But they're not, I would say they're not widely used.
Understood. From what you're saying is a good future state where the object's in the cloud and it's getting its grading from the civil engineer and its surface finishes from landscape architecture, for example, that maybe the interoperability needs to be in a cloud platform and each one authors in their own platforms, but it's inheriting its parameters. And so the one source of truth is the cloud-based one, perhaps. Do y'all see that as a future state?
Yeah, things seem to be going that way, I would say, definitely. I mean, linking of topographies needs the cloud as a CDE to happen. And there's data holding in the cloud. That's the direction that CD is going, essentially. I think the eclectic set of tools, I mean, things are possible. All of these civil items can be incorporated to varying extents into a BIM, I mean, a Revit world, if we're looking at that. But the eclectic set kind of defeats, in a sense, right? I mean, the purpose of BIM, which is integrating and simplicity and single source of truth. We are doing it, but ideally this would be a diminishing set of tools towards a sort of an integrative approach, which is I think the essence of BIM.
Well, with that, Lauren, Radu, it's been a real pleasure to get to learn with you over this year, working on the 22 version of the specification, and especially today, where we get to hear you share your insight and your work in these areas. I'd encourage anyone who's interested to download a copy of the LOD specification. And particularly if you see things in there that you don't like, let us know. Our information and contact information is there, and we want to hear your feedback. We want to learn how to make it better. And if you see things that you do like, let everyone else know. The way these documents get better is they're shared and they're used on projects. And the goal is to have made this easy workflow. Next week's webinar, we'll be focusing on an interview with Matthew Bird, and we're going to be talking about the upcoming conference for the Reality Capture Network. And I think I'm going to just have that opportunity to ask Matthew a lot of questions about what's the conference, where does it tie in? I'm going to take some of the thoughts that Radu and Lauren have shared with us today, and I'm going to be asking him about how does this apply to landscape architecture, civil 3D, subgrade civil utility locations with things like ground penetrating radar. So it's going to go a lot beyond laser scanning. It's going to be talking about drones and multiple facets of capturing a reality, and then how that gets simulated, which is then tying back to the model. And then what Radu alluded to on the digital twin aspect of a granularity and a frequency of updating of that information. And how is that achieved? If we're working on taking reality capture and tying it back into this digital twin that we're all shooting for. Again, Lauren, Radu, thank you all so much for your time. And these recordings will be posted on BIMForm Global's YouTube channel. And again, also links on the website. If you're interested in this upcoming webinar or future ones or the spec, that information is provided at bimform.global.com. Thank you all.
Thank you.
Well,